Here is another example. In this example, he's asking us to find I1 and I2. So the given circuit is a Z parameter circuit. So here I have all only real numbers. So basically these are nothing but resistors. So it's a DC circuit. We can clearly see the given source is a DC, and you have only the real parts of the Z parameters. So it's a DC resistive circuit. So our goal is finding I1 and I2 in this circuit. So first thing you need to know, you have to remember these formulas. V1 equal to Z11 I1 plus Z12 I2. V2 equal to Z21 I1 plus Z22 I2. You have to remember these formulas. Okay, I mean, you can clearly see, say for example, if you want to find Z11 is nothing but this is voltage, that's current, V1 over I1, where I2 equal to 0. So if I make I2 equal to 0, I will find Z11 is V1 over I1. So that's how you can remember. I mean, voltage must be equal to current times impedance or resistance. So we have impedance times current. That will gives us the voltage. So voltage plus voltage, and voltage equal to voltage plus voltage. That's how you can remember these formulas. Okay, now, so I already know Z11, Z12, Z21, Z22. So that's given in the circuit. We don't know what is there inside this box. This box might have something, some electronic components or electrical components. So by using given parameters, I can say most of them are resistors in this case. So we can take them as resistors and then solve for the current and input current, which is I1, and probably output current I2. So here, what I'm doing here, I am substituting Z11, Z12, and Z21, Z22 in these equations. So V1 equal to 2I1 plus 4I2, and V2 equal to 8I1 plus 1I2. So now here I have 4 unknowns, but I have only 2 equations. Okay, I have V1, V2, I1, and I2. Those 4 are the unknowns, but I have only 2 equations here. So I need to come up with more equations. So here, to get more equation, I can write a KVL in this loop. If I write a KVL in that loop, I'll get an equation. So the KVL equation there is 20 equal to 2I1 plus V1. That's my third equation. Okay, and the fourth equation is, see, I2 current is entering here, so, and that's a voltage drop, but you have V2 as a positive there. So can I take V2 equal to minus 20 times I2? Okay, that's a resistive load. Resistive loads always consume energy. So if I2 is entering here, okay, so I2 is leaving there, so must enter there, right? So this must be positive, that must be negative. But your V2 is in opposite side, so that is the reason we have negative there. That's most of the time we make a mistake at that point. So here I have 4 unknowns, 4 equations. From here onwards, it must be a simple one, solving those 4 equations. You can use the substitution method. So most probably I'm going to use the substitution method here. I'm going to substitute equation 4 in equation 2. So when I substitute equation 4 in equation 2, so V2 equal to minus 20I2, that's what I substituted there. So minus 20I2 equal to 8I1 plus I2. So when I simplify it, 8I1 plus 21I2. This is one equation with 2 unknowns. So I need to get another equation with I1 and I2. So to do that, what I'm going to do, I'm going to substitute equation 3 in equation 1. So here I substituted equation 3 in equation 1. So V1 equal to 20 minus 2I1. So that's what I have here. I substituted V1 equal to 20 minus 2I1. So when I simplify this, it's going to be 4i1 plus 4i2 equal to 20. This is my probably this is fifth equation and sixth equation. Now I have two unknowns, two equations. It should be easy for us to solve it to find i1 and i2. Now for equation 6, I'm going to multiply with 2 on both ends, on both sides. So it's going to be 8i1 plus 8i2 equal to 40. That's extension of 6. Maybe I can label that as equation 7. Now I have equation 5, 8i1 plus 21i2 equal to 0. So I'm going to substitute these two, cancel out. It's going to be minus 13i2 equal to 40. So if I simplify it, I will end up with I2 equal to 40 over negative 13. So it's a negative current, minus 3.076 ampere. Once I have I2, substitute I2 in any one of the equation. I'm going to substitute it in here. So 8i1 plus 21i2, which is minus 3.076 equal to 0. So I1 equal to, after solving this, we'll end up with 8.07 ampere. That's I1 and I2. Okay, so to summarize, here we have two port networks where Z parameters are given, Z11, Z12, Z21 and Z22. These are all ohms, so basically mostly those are equivalent to the resistor values. Now our goal is finding I1 and I2. Okay, so you have to remember these two equations to find the Z parameters, and based on those two equations we wrote these two, and again apply KVL here, another KVL there. That's how I wrote 3 and 4 and solve those 4 equations to find I1 and I2. I will stop it here, make another video, similar example based on the H parameters. Thank you.